But as you advance in your coursework and you move closer and closer and into your doctoral study, your actual doctoral project or your dissertation study, then this list right here actually becomes a rather short list, and you'll need to probably add in a few other details based on the statistical tests that you're actually running for the different disciplines that we have at Walden. Some disciplines do not require, some disciplines require more information than other disciplines. I can say firsthand that for those that are in public health with an emphasis on epidemiology is very heavy in biostatistics, and so those who are epidemiology track are going to want to include more information than, let's say, those that are focused more on education. Even though in an education doctoral study it may not be required, you can always include the information, but that all gets back to your committees and chairs and requirements for each department. So the components to include, we want to include the research question, because you may have more than one research question and you want to re-identify that again in your paper. You want to identify the test statistic or the statistical test that you applied to answer that research question. You're going to identify the dependent variable or the groups. Then you'll identify the independent variable. You want to include here the statistical assumptions. The statistical assumptions are those assumptions which relate to the statistical test that you're running. You want to identify if the statistical assumptions were met or were any violated. It's important to include that, because if all of your statistical assumptions are met, then we can go ahead and trust and accept the results that you have. But in the real world, it's very difficult to meet all of these statistical assumptions for any statistical test. And so you may have some statistical assumptions that are actually violated, but you still run your test. You just want to bring to the attention of the reader that, wasn't able to, based on the real world data, this assumption could not be met. So you'll have to adjust for that in your conclusions. We always want to include sample size. That's very important. And the sample size is generally designated as a small n equals whatever the number actually is. If you're looking at the larger group size, you might want to use an uppercase n and then a lowercase n for each individual group. But once again, you'll have to work with your committees and chairs to see which format they actually want you to use. It's always good to provide the descriptive statistics of the variables. The descriptive statistics, if you're looking at gender and you've got females, you may want to show that you have 82 females. Their age ranges went from 18 to 35, with the mean age range with a mean of, say, 27.5 years. You include that in your write-up, so that way it gives a better picture to your reader of what your sample actually is. Because, like I said earlier, previously, your write-up brings clarity to your research to your reader, because your reader did not collect the data. You know your data better than anybody. You're the expert, and you have to convey that information to the reader. After you do your analysis, you want to identify those variables found to be statistically significant and those variables found not to be statistically significant. And I have an example for multiple linear regression where we'll actually see how this plays in. It's not always possible to say that you have variables that are not statistically significant, especially on the statistical tests that you'll be conducting. If you're doing an independent samples t-test where you have two groups and one outcome, you're really not going to say that these variables were not statistically significant. You would say that the analysis was not, but there aren't any particular variables that are not statistically significant. But when we get to multiple linear regression, where you have, say, 5 independent variables, the first 2 may not be statistically significant, but then the latter 3 actually are, and you want to be able to identify those. We always want to include the level of significance, the p-value, or really our threshold for the false positive rate. Not only the threshold for your research study, but actually the output from SPSS. And SPSS identifies it as a SIG, an SIG. It doesn't say p-value, but in essence it's the same value. Now this is one of the the parts that confuse the students. There's always, as for those of you who run SPSS, it puts out table after table after table with plenty of information. There is a distribution associated to the statistical significance of that p-value. And for those of you who've run SPSS, you've probably seen it. It's either a t-score or an f-value. It's important to include that distribution in the same sentence as the p-value result or the sig-value result. That distribution is how SPSS actually calculates out the p-value. So in place of just saying the p-value equals this, you put in the actual distribution associated to it, if it's a t-score or an f-score or an f-value, and then you list in the p-value. And we'll see that in one of the examples. Here's another component which is also necessary. We have the point estimate, and the point estimate, say for instance like the mean or the beta, when beta comes to a linear regression, the point estimate comes from your sample. Whatever your sample is, if you calculate the mean, you get a mean, that's a point estimate. If we look at a median, that's a point estimate. If you run a simple linear regression and it puts out a beta, that's the point estimate. Following the point estimate, you want to include the population estimate. And the population estimate is that confidence interval. Because in statistics, especially in biostatistics, what we are interested in is actually the population estimate. The point estimate changes from sample to sample. And when we're collecting samples from a single population, that point estimate is going to change. But it's that population estimate that we're really interested in. When we look at a difference in means for a straightforward t-test, if that population estimate includes the value of 0, then we know that it's not statistically significant. We're not really concerned about the mean so much, but we want to know whether or not the population estimate includes the value of 0. If it includes value of 0, it's not statistically significant. But if it does not include the value of 0, the results will be statistically significant. The same goes for when we look at binary logistic regression. Binary logistic regression, the output, instead of surrounding the population estimate, doesn't surround the value of 0, it actually surrounds the value of 1. So if the population estimate includes the value of 1, you'll find that your binary logistic regression results are not statistically significant. But if they do not include the value of 1, then you'll find that they actually are statistically significant because we're looking at the odds ratios where one odds is divided by the second odds. In the last sentence is you want to interpret the statistical analysis. And the interpretation of the statistical analysis we'll see actually in the example for multiple linear regression. It's really just a one-sentence line. You're not interpreting your entire research study. Your interpretation of the data analysis is going to be done in the conclusions. But when you're presenting your research results, you have to interpret the actual numbers for the reader to understand. And I'll give you an example of that. I'll identify that. The last part is that we're looking at, the last thing to include is the hypothesis retained. You're either going to retain the null hypothesis or you're going to reject the null hypothesis based on your findings. And you'll see that in one of the examples. So let me move forward here. So